Right, hi everybody, welcome back again. This video will cover the topic of acid deposition, which in our syllabus is topic 6.4, and it concludes topic 6, atmospheric systems and societies. You're probably familiar with acid rain, but acid rain isn't the only way that acid pollutants can get into the environment. We'll talk about in terms of dry deposition and wet deposition, depending on whether the primary pollutants are dissolved in rain or snow or attached to things like dust particles, solid particles, which can then come down to land. I'll very quickly go through the main terms, which you can see above my head here. Number one, the primary pollutants that we'll look at are nitrogen oxides and sulfur oxides, which largely come from the burning of fossil fuels. Secondary acidic pollutants are formed. If NOx and SOx dissolve in water, they form nitric acid and sulfuric acid, respectively. These acidic pollutants can have indirect and direct effects. We can talk about the effects on living things, or the effects on soils, or the effects on water bodies like lakes and rivers. The impacts can be a long distance away from the source, sometimes in terms of different countries, a long distance away from source in some cases. And then finally, we'll conclude by looking and evaluating pollution management strategies. You will be familiar with these three pollution management strategies by now. We've seen them many times before. We'll look at changes in human activity, regulation of the emission of the pollutants in the first place, and then finally, and least desirably, as you know, cleaning up the pollution once it's entered the environment. Okay, so pretty much I've already given you a summary of what the syllabus says, but we'll look at it in a little bit more detail. There's four main points here under knowledge and understanding. Number one, you need to know that the combustion of fossil fuels produces sulfur dioxide and nitrogen oxides, and these are primary pollutants. They may be converted into secondary pollutants either dry, by attaching to solid particles, or they can dissolve in rain and snow, and therefore we refer to that as wet deposition, or usually acid rain. Possible effects of acid deposition are on water, living organisms and soil. They may be direct or indirect. We'll look at that in a little bit of detail. Direct effects include effects on cells of living organisms, especially plants in forests. That's where we see the biggest effects. There may be indirect toxic effects where changes in pH or decreases in pH because of acidity make toxins such as heavy metals more available, especially in water. And then we'll look at other indirect nutrient effects in which changes in pH leach or strip nutrients away from soils. Number three, the impacts of acid deposition may be limited to areas downwind of major industrial regions, and in some cases these might be many kilometres away, not even in the same country. My country of Great Britain, throughout the 1980s and 1990s, less so now, was referred to as the dirty man of Europe, because many European countries such as the Netherlands, Germany, France suffered greatly, especially their forests, from acid deposition as a result of primary pollutants released from Britain, especially because of the great amount of coal that was burned over a very long period of time. And then finally we look at pollution management strategies, and you can see them there. One, changing human activity. Number two, regulating emission. And number three, cleanup. Under applications of skills, we need to be able to evaluate these pollution management strategies, and I'll try and do that in a little bit of detail in this video. Okay, let's move on. So as we said, NOx and SOx, nitrogen oxides and sulfur oxides, result from the combustion of fossil fuels, obviously cars and trucks. This is a coal-fired power station, actually very close to where I grew up. This was pretty much the view from my bedroom window growing up. This is called Fiddler's Ferry Power Station. one of the biggest coal-fired power stations in Europe at the time. It's actually closed down now. These primary pollutants may fall to the ground as particles, or as I said before, they can dissolve in water, either in rain or snow, and fall in the form of acid rain. We distinguish that as dry deposition and wet deposition. The longer these primary pollutants remain suspended in the air, the more likely they are to be oxidized and dissolved, and therefore form, well, you can see here, nitric acid or sulfuric acid, which is the secondary pollutants we talk about. And at the risk of repeating myself, the rainfall might occur so that these secondary pollutants fall to the ground many, many kilometers away from where the primary pollutants were actually originally formed. I've said here that's especially the case now because many factories that burn fossil fuels have chimney stacks, maybe not this in this case, chimney stacks that are many, many meters tall, and therefore it increases the spread of these things before they fall to the ground as secondary pollutants. Okay, the effects. I talked about direct and indirect effects. What I thought was more easy to understand is to basically split this up into the two major effects, one on water and secondly on living things. The main effects in terms of water in lakes, because it's still water that's not flowing and is not replaced, and the main effects on living things are on forests, especially coniferous forests, which we see in Northern Europe. The effects on lakes are reduction in biodiversity. Change in pH of the water certainly affects which animals and which plants are able to live there. And obviously big effects on the food webs that live in those water bodies. Acidity is especially bad in terms of the effects on fish fry or baby fish because they have such very thin membranes, and obviously they depend on the gills, the movement of oxygen across the gills for oxygenation of the fish fry. We associate acidity of lakes with very, very clean water. It's very strange actually. This water looks very, very clean, but it's actually very, very acidic because acidity reduces turbidity. Turbidity in water bodies is not necessarily a bad thing. We associate it with, as we saw when we looked at indicator species, increased pollution not only decreases biodiversity, but increases certain species that are able to live under those conditions, that are pollution tolerant. A very good indicator of acidity of water is the growth of white moss. It's very tolerant of low pH. And then finally, another big effect on lakes especially is low pH, increased acidity, causes the leaching of heavy metals from rock. That includes things like cadmium, copper, aluminium, zinc, lead. And those heavy metals can be toxic once they're in the water, once they're dissolved in water. Another effect could be that if water bodies are used for extraction for human consumption, these heavy metals can get into water for human supply as well. Okay, in terms of living things, especially forests, damage to lipids and membranes, which lead to death of plants. We associate that very much with the loss of needles from coniferous plants and large-scale die-off of coniferous forests. That's been the case in Northern Europe, especially Scandinavia. And again, like I said before, that has been put on the door of the British government because of the large-scale burning of coal over many, many years, especially in British power stations. Sulfur oxides directly interfere with photosynthesis, especially in conifers. The shedding of needles and therefore death of coniferous forests. Low soil pH interferes with membranes, especially in the roots of plants and the roots of trees, and makes it more difficult for plants to uptake water and nutrients. And then finally, another indirect effect is that when soil water becomes more acidic, and this acidic water moves through the soil, infiltrates through the soil, it takes plant nutrients with it. Some of those nutrients, by the way, include the metals that we saw before, which are important in smaller concentrations. So these nutrients are washed away from the soil, maybe into the aquifers, and therefore are not available for uptake by plants anymore. Obviously, plants are at the bottom of the food chain, and if you interfere with plant material over large scales, you can expect big effects on the food web in general in that area. Okay, moving on again. Distribution. Well, again, at the risk of repeating myself, these primary pollutants stay in the atmosphere and may fall as secondary pollutants many miles or many kilometres away from their source. There are actually natural sources of acidity, including volcanic activity. Some heather and bog moss produce acidic conditions as they grow. Large concentrations of carbon dioxide in the atmosphere as a result of, again, combustion of fuels lead to a greater dissolution or greater dissolving of carbon dioxide in water, which causes carbonic acid. That's even seen on the scale of oceans now, where we are seeing ocean acidification as a result of more carbon dioxide in the atmosphere. In terms of combating the problem, there are natural buffering capacities in certain environments. So therefore, limestone is naturally alkaline and therefore can buffer increased acidity. There are other rocks that are actually naturally acidic, like granite, and these have low buffering capacity. Buffering meaning the ability to neutralize the acid that's in the environment or in the water. And certain areas in the world seem to be much more affected than others. You might think that because it's acid deposition occurs on a global scale in pretty much all industrialized countries, it will be spread equally around the planet. But that's not the case. There are greater effects in Sweden, Norway, Denmark, Scotland, Germany, Northern Europe, the Netherlands, Austria, and the east coast of the US. This is related to buffering capacity of soil and water in those areas, but also the movement of winds, which are predictable around the world, and rainfall, which is also more or less predictable. It's also, as I said, it's also related to the buffering capacity of soil and water in those areas. So I copied a map, and these are the most affected areas, as you can see, largely the Northern Hemisphere. Much less so Africa, apart from parts of South Africa, and large parts of South America and Australia seem to be unaffected by acid rain. Largely a problem that we associate with the Northern Hemisphere. All right. Finally, to conclude then, we'll look at the pollution management strategies with our three subtitles. So number one, we can alter human activity. We can find ways to burn less fossil fuels, to move away from using fossil fuels to create electricity. Greater reliance on renewables would help to solve that problem. Reductions in how many private vehicles we use. We've seen this before. We can encourage carpooling, tax cars and fuels to a much greater extent. We can make fuels more efficient and less rich, certainly in sulfur oxides. Encourage people to use bikes or walk. Encourage people to use electric cars, maybe. And also we can look at, I think we'll cover this maybe in one of the others, we can look at ways to scrub sulfur, especially from fuels, either by using catalytic converters in cars or scrubbers in factories and chimneys and power stations. All right, in terms of evaluating that, I don't think MEDCs have the right to tell LEDCs, developing economies, that they have no right to use polluting fuels to develop their economy. Or at the very least, it's hypocritical to do that. Number two, we live in a society that, especially in MEDCs, that are very, very dependent on burning fossil fuels even now. There's many blocks and it's very difficult to convert to renewable energy, although we are on that journey at the moment, and hopefully we reach the end of that journey during your lifetimes. And another problem is that fossil fuel producers, especially the oil industry, very powerful, very strong lobbyists, especially I would suggest in the United States. So it's very difficult to get those industries to change. You might be able to think of more, and you might be able to evaluate that a bit better than I have. We can discuss that more. In terms of regulating the sources of pollutants, I did mention this, probably in the wrong place, but we can scrub sulfur oxides from fuels. It is possible to clean sulfur from coal to some extent before we burn it, or it is possible to capture that sulfur before it's released into the atmosphere. Another way of doing that is to fit a catalytic converter on the exhaust of your car. I mean, pretty much all modern cars have that anyway. We can burn coal with agents or chemicals such as limestone, calcium carbonate, that actually neutralise the acid before it's released. There we go. We can use catalytic converters. In terms of evaluating these strategies, they can be expensive. You can force industry to make these changes, but those costs will be passed on to the consumer, which is not always welcome. Catalytic converters can be very, very costly. They use very expensive materials like platinum to achieve these cleaning measures, and they can be expensive technologies. Scrubbers can be very expensive technologies to maintain. Okay, and then finally, clean up of the environment once this issue has happened. Because acid rain has been a problem for so long, dating back to the dawn of the Industrial Revolution, we have to face the fact that we need to clean up our environments once these issues have occurred. So one thing we can do is use chemicals to buffer soil or buffer water. So we can add limestone, for example, ground up to water or soil to try to neutralise the acids once they're in the environment. We can encourage recolonisation of damaged areas by plants. Obviously, if we don't clean up the acid problem in soils, there's no point reintroducing plants and animals to an already damaged environment. It's got to occur in tandem with cleaning up the soil and cleaning up the water. Because, as I've already mentioned, this is a problem on a global scale, even though it affects specific parts of the world more than others, we need international agreements. In 1999, the United Nations held a meeting in Gothenburg, which became the Gothenburg Protocol. And this was a very general agreement between these Northern Hemisphere countries, especially that I've already talked about, to try to solve the issue of acid deposition and acid rain. As you'd probably expect, it was less than successful, partly because of the strength of the oil lobby in those countries. In terms of evaluating this, we could talk about how it's certainly better to treat the cause rather than, in this case, the symptoms of pollution. Cleaning up measures are always a last resort. But as I've already suggested, this is already a global problem, and it's been a global problem for, well, certainly more than 100 years now. Sorry, a typo there. If acidification continues, remediation must carry on indefinitely. I've already alluded to that. Unless we solve the problem of these things getting released into the environment in the first place, this is just a continuing treadmill where we've got to continue clean up because we're not solving the problem of releasing to the environment in the first place. And then finally, as usual, as I always say about United Nations agreements especially, the UN has no teeth and no power to enforce these agreements. International agreements are very difficult to police. And unfortunately, because of the scale of this problem, where effects might be in different countries to countries where they're released, these international agreements are necessary. And as we've seen over recent years, it's very easy for countries to actually renege on their agreements or remove themselves from international agreements, like we saw with the Paris Accord. Okay, so that concludes acid deposition. Hopefully it made some sense. I don't think it's a very complicated topic, but there is quite a lot of detail within it that you need to go back over. All right, so as usual, take care of yourselves and your family, everybody, and I will speak to you in the class this week. Okay, bye-bye.